In this question, it is given that the relation R equal to ordered pair AB such that GCD of A and B is 1 and 2A is not equal to B, where A and B belongs to Z is. You have to find the correct choice. That is, you have to check the reflexive nature, symmetric nature and transitive nature of R. It is clear that when he is writing GCD of A and B is 1, then this is automatically true except for the case at least one of them is 1 or minus 1. In all other cases, if GCD is 1, then automatically 2A will not be equal to B. If none of A and B is 1, in that case, if 2A is equal to B, then GCD will be at least 2. Therefore, I will take care of it. That is, this is of importance only if at least one of them is 1 or minus 1. In all other cases, this is automatically true once GCD of A and B is 1. And first of all, I check the reflexive nature of R. And because in R, those ordered pairs are there when A and B are belonging to Z, means R is a subset of Z cross Z. And therefore, for R to be reflexive, 1 1, 2 2, 3 3, 0 0, minus 1, and so on, all of them should belong to R for R to be reflexive. Clearly, for example 2 2, this is not belonging to R because HCF of 2 and 2 is 2, and in R only those ordered pairs are there for which HCF is 1. GCD or HCF is same thing, you must be knowing it. Hence R is not reflexive. Now it seems that relation R is symmetric. Because why it seems that R is symmetric? Because if GCD of A and B is 1, then GCD of B and A will also be 1. Hence, it seems that if AB belongs to R, then BA will also belong to R. But I told you that this is of no importance so far none of them is 1 or minus 1. But if at least one of them is, then this will become important. Say if I take A equal to 2 and B equal to 1, in that case GCD of A and B will be 1 and 2A not equal to B is also satisfied for this case. That is, I can say 2 1 belongs to R. But note that 1 2 doesn't belong to R because agreed that GCD of 1 and 2 is 1. But this case doesn't satisfy this because this ordered pair means 2A is equal to B. Hence, this ordered pair doesn't belong to R. That is, 2 1 is belonging to R, but 1 2 is not belonging to R. Hence, R is not symmetric because the condition for the relation to be symmetric is whenever alpha beta belong to R, then beta alpha should also belong to R if for every ordered pair alpha beta. But there is an ordered pair 2 1. This is belonging to R, but 1 2 is not belonging to R. Hence, R is not symmetric. And it is clear that R is not transitive also because, for example, if I take A equal to 4, B equal to 7, then the ordered pair 4, 7 belong to R because GCD of 4 and 7 is 1 also, and this condition is automatically satisfied as I told you in the very beginning. That is not required to check. And I take one more example, 7, 8. This also belong to R. I have taken one number as 7 because 7 is prime, and it is easy to see that if 7 is prime, its GCD with any natural number will be 1. Now it is clear that 4, 7 is belonging to R, 7, 8 is belonging to R, but 4, 8 doesn't belong to R because GCD of 4 and 8 is 4. That is, for this case, this condition will not be satisfied. Hence, we have found a case in which this is belonging to R, this is belonging to R, but this is not belonging to R. Hence, R is not transitive. Therefore, I can say R is neither reflexive, not symmetric, nor transitive. Hence, it is clear that first, second, third are wrong, but fourth is correct. That is, I can say fourth choice is the correct choice.